Our final presentation today is from Woodbury University with Mobile Cooling Rooms of Los Angeles, employing an ancient technology in a modern application. Professor Berenika Boberska leads the team. Berenika, welcome.
Okay, thank you very much. So before I share my slides, we wanted to make a little demonstration. This is a ceramic form that we've made, and we're just gonna wet it, and we're gonna measure the temperature difference at the end of the presentation in 10 minutes. It's not exactly a perfect condition because it's freezing cold in Burbank today. The hotter it is, the more differentiation we have. So let me just set up my slides. So mobile cooling rooms for Los Angeles. So extreme heat, as we've heard already, is radically changing our cities and the environments of our cities, and is radically changing Los Angeles and its streets. So it's likely, because of climate change, to become more extreme and hotter and drier, and it's actually going to be dangerous to be outside for any extended amount of time during the summer, the height of the summer in Los Angeles. So it radically changes our understanding of urban space as well. Now, we are able now to map these heat islands, and from that, we are able to see how this extreme urban heat is actually very unevenly distributed in the geography of the city from the point of view of communities, income brackets, even race and things like that. So we are seeing a sort of a polarization as well. And it is the urban streets that are becoming unlivable and dangerous. And we've seen, especially the homeless population suffer from heat-related illness and death. So this is a very urgent situation, and just overlaying maps of the cooling centers sort of really shows this quite strange amount of, very low amount of cooling centers near Los Angeles, which is where we need them most, near the downtown Skid Row. And these are also places not dedicated to the idea of unmateriality of cooling. There just happen to be lobbies in public buildings where perhaps the homeless don't feel a kind of a true welcoming and dedicated space. So our project becomes quite monastic, as in we wanted to just zoom into a very specific thing, the cooling aspect, as the most urgent, perhaps, intervention, employing an ancient technology to Los Angeles, a very sort of fast-forward contemporary city, and sort of devising almost a new typology of external rooms for the sidewalks, for the streets of LA. And LA is fast becoming the global south. And so we thought the best way to do this is to learn from others, from other geographies with whom we are now sharing the same extremes. So indigenous technologies, ancient and contemporary, especially in the Middle East. This is a terracotta jar in Egypt used to keep water cool for drinking. But there's also something quite ingenious about using these gula jars in the windows where the breeze sort of goes around them. And it becomes a sort of very, very low tech, very ingenious way of basically air conditioning the space. So evaporation from porous jars of water in windows. This is also expanded in the Middle East with cooling towers. In India, terracotta is used also on roofs for the same purpose, walls. These are some contemporary applications of similar things that we've done, of terracotta tubes that are sort of sprinkled with water and the air blows through them. So just some examples from other parts of the world. Also, just anything, these are very inventive kind of low-cost things, anything that allows air to go through it and has a lot of surface area for water evaporation will bring down the temperature by several tens of degrees. But we've realized that it's also part of materiality that's important and feeling. So we wanted to look at materials that are much more sort of not transient, not temporary, or still cheap, but not something to be discarded. Mainly because of the psychology of being outside, living on the street. So we wanted to sort of elevate the materiality of it. So we chose to work with ceramics, low fire or bisque fired clays with high porosity, which have a sponge-like microscopic structure. So it works very much like sweating, and the evaporative cooling that happens is most dramatic when it's actually super dry and super hot, which is what happens during the heat waves in Los Angeles. So up to 11 degrees Celsius, I'm sorry, I didn't translate that, but it's quite a radical drop. You know, and we've got a sensor here that we can actually test at the end of the day, at the end of the presentation. So the design process, the more surface articulation, and I can kind of show our first sketches, the more surface articulation there is, the more chance of water evaporating with the wind going through. And these are ceramics that we've kind of cast ourselves, that we've fired ourselves. So we kind of took inspiration from nature in sort of dividing up the surfaces to something quite elaborate. This is a 3D printed sample, which is maybe something we will use in the end for sort of manufacturing these units. But we played initially by hand to sort of get a feel for these ceramic forms suspended in a structure. So I'm just going through the process. This is very much like dough and stretching it stretching the clay on a press, and then cutting it and molding it into these vessel-like shapes. And these are fired now. So all of these are now fired forms that are meant to capture a flow of water and absorb it, and then gradually evaporate it. So ceramics are quite strange animals. So they don't actually. Oh, let's look at this one. So this is the one that we've been dunking in water just for 30 seconds at a time. It is dry to the touch, although very, very cold. So it's not wet. So that's quite important. Everything gets absorbed inside, and you only need to switch on the sprinkler system 3 times a day for 5 minutes and no more. So very little water goes a long way. And these are just some of the sort of textures we've been exploring, how to increase water absorption. So we've become quite obsessed with this technology, but hopefully it offers a sort of a system to use. So this is an extrusion. So an extrusion can make these tubes, and these can be collected into clusters. So some of these things are replicable. And of course, how do you channel water through them? And so we've kind of devised a system where the water distribution is actually part of the suspension of the ceramic forms. So this is just process. And here's the final piece. And choosing a very simple one, how do you suspend that in a structure? So very simply, it's like a kind of a timber trellis with metal tubes that suspend these vessels, and the metal tubes carry the sprinkler system or a mister system, which is just switched on 3 times a day or maybe 4 at the height of summer. And the rest is up to passive evaporation. So this wall unit is 3 ceramic vessel thick, and each ceramic is maybe a foot in length. It's important to build depth because that's how there's most contact between the ceramic and the air. And so these are systems, and we're imagining each wall to be 10 foot high, 10 foot long, full of these vessels, and they stack together tightly like books, but hinge open. And so each one of these hinge systems can combine with another to make a room, to make an enclosure that can actually vary or combine to form larger spaces as needed. So something like that could fit in one of those maybe parking places, plus 1/3 of a pavement, or a leftover space. Or we'll need to look for nooks and crannies. And so we really enjoyed the previous presentation of USC, because that's really what we need to do next. So it was very inspirational. We've realized that we need to do that. But a proposal for future development. So we just want to test the system and let the system be changed by what's needed. We have some ideas of what uses would go in there, because these are rooms. We think it's important, the psychology of a room. So a library room, a cooling porch, a reading room, a shade pavilion, yeah, of course, but rooms are more intimate, right? So maybe it's a place to play chess just between 2 people. So it's about this sort of temporary domesticity, perhaps. So construction of a full-scale prototype. We would love to do all this. We have a very small team here, but a very, very, very dedicated one. And we're lucky to have here at Woodbury, that's why we're in this place, 2 kilns and 3D printing of clay. And of course, Joshua Stein, who's kind of looking after this facility here, is helping us look at digital ceramics as well, although all of these are handmade as research. So these are the resources that we have at Woodbury. We've tried to put prices on things, but it's a sort of a moving target. We hope to make a room. We hope to make a room and figure out how much this really costs. These are very cheap materials. The ceramic clay is super cheap, so is timber. It's just how to kind of do the most expensive thing is the water system, but it's a very standard misting system for a garden or a restaurant. So and it uses very little water, as we found out. So anyway, that's our proposition. And yeah.
Veronica, thank you so much. I'm sitting here thinking how remarkable it is how these 3 presentations started out so broadly and then have increasingly narrowed down in a wonderfully choreographed way, though unintentional from my standpoint. But anyway, thank you all. Craig Ryder, Senior Director, Sustainability and Energy for LA Metro. Craig, thank you so much for your time. I'm sure you have questions. So if you can do just 3 or 4 minutes of those, that'd be great.
Sure. Thank you, Eugene. Veronica, and Woodbury team, I can see you're all very passionate about this technology. Quite exciting. And I'd like to see all 3 of the school's projects come together, because it seems like they all could work off each other. As Eugene mentioned, my questions kept changing as the discussion went on, the presentation went on, because you kept laying out more details about it. But I would like to better understand, like, how, you talked about the idea of the cooling room and the potential for, I think in many ways that would kind of demo the technology, but how you could look at, marketing isn't exactly the right word, but more mass producing that, so that it's something that is out, that could potentially, kind of in USC's presentation, something that could be at each individual location, and potentially be able to provide cool air in conjunction with other features to reduce the heat impacts. Have you thought about how you would take it from a demonstration of a cool room to a wider spread availability for others?
Mm-hmm. Well, yeah, I think that's, honestly, that is the next step. But I think one has to have, with something like this, first a demonstration that this is possible, and this is possible cheaply, and this is possible with materials that don't look cheap, that are beautiful, that are, perhaps elevating a certain sort of stigma of street furnishings or street infrastructure for those who live on the streets. So we felt that we needed to demonstrate this first, but we are aware, you know, especially after USC's presentation, and we knew that we need to differentiate these and sort of find not only sites but groups to work with to infect the system with a need or a function within. We have some ideas, but these are really very spatial constructs that need partnerships with perhaps people who already work in Skid Row, as we know, but also with the city for locations, because I think this prototype offers also other uses when it's not summer, when it's a day like this. These could provide other things because of their mobility and perhaps the way they feel can actually be in parks like the Gladys Park, and can actually serve other functions than cooling. So we were thinking of it as a kind of a gift to the streets of Los Angeles that can be used in summer by the homeless community, but then perhaps at other times for other functions, for creating maybe public spaces. So this is still a system that needs partnership, that needs the infection of differentiation and things like that. We were thinking about fabrics for the roof and other things and details that, you know, there is a mobile table, there is a sort of an element that is crafted. I think what we wanted to bring to this discussion is the idea of hand and craft again, because a lot of the solutions tend to look fast and or tend to have materialities that speak of sort of discardability or other things. So I don't know. We wanted to attack it from a different angle, and hopefully to find through this community as well, to find partnerships to develop this further, to plug in with others, to collaborate. So yes, we know that, yeah, we were very obsessed with providing a kind of a system. Yeah.
Well, I know we're out of time, Eugene. I just want to say, you know, it is a tried and tested, you know, technology, the use of clays for cooling, and you have a very functional opportunity here to provide, you know, a solution for this. And so I wouldn't overthink the aesthetic part of it, and just know that you're headed on the right path. Thank you for your presentation.
Thank you.
Thank you, Craig. Thank you again, Veronica.